So there's a couple different formats of log equations. There's what to do if there's a log on just one side of the problem, and what to do if there's logs on both sides of the problem. So if I look at my first four examples, logs only on the left, logs only on the left, logs only on the left. Here we finally have logs on both sides, and we'll get to that too. You solved log equations last year, but I've not seen too many actual Regents questions on it, so I'm not sure how much Mrs. Ziegler really spiraled it in there for you. But I'll ask, does anybody know what you would do to go about solving example 1? Olivia? Right, you translate it. You would just take it out of the log language and put it in exponential language. So the base of 2 raised to the other side 5 equals whatever you're taking the log of. And then just solve for x. So subtract 1 from both sides. That's 32 minus 1, which is 31, equals 4x. And divide by 4. So that one was straightforward because the log was already isolated. If we jump to the second one, we can't translate it right out of the gate because it's not isolated yet. So you first subtract your 7 from both sides. Divide by your 3. And what would your translation look like here? Mitch. E to the negative 1/3, but yeah. Base of e technically, so he knows that. E to the negative 1/3 equals x. Now in the most simplified, best presentation, that would be 1 over e to the 1/3. That could also be 1 over the cubed root of e. It would kind of depend on what your multiple choice options are. Any questions on that? Next exercise here. So here we have logs are just on the one side, but we obviously have 2 of them. So what are your thoughts? What do you remember about how to handle this? Aiden? I feel like you're on to something though. Do you have like a gut guess? Even if you're not confident in it? No. We can't do anything unless there's a single log. So this is where, Nate? Right, this is where condensing comes in. So I would take the 2 logs and condense them with subtraction turning into division. And now that I have it as a single log, now I can translate. Can everyone just take a moment, because it's been 3 weeks. Look how beautifully sunny it is out there for like probably the 5 minutes that this is going to last. It's like we should just move class out there and just take it all in. It'd be a little cool. But that, look at you. You can't see how pretty that little baby tree is without sun shining on it. Now we can see. Abby's ready to move on. Here we go. See? It's gone. Aren't you glad I made you turn around and look? So the base of 4 raised to the first power equals x plus 2 over x minus 1. How do we solve this? Bailey? Correct. So we'll multiply this x minus 1 away. Get all your x's together. On the left, your non-x is on the right. 3x equals 6. X equals 2. You know what I'm not doing and I should be doing? Checking. And really, you can't so much as check for the right answer without a calculator, but you can check for an extraneous solution. Like something that if you plug it back in, tries to take the log of a negative. Now 31/4 plug back in, that'll be fine. 1 over e to the 1/3, plug back in, that's a positive number, so no issue trying to take the natural log of that. Here, if x is 2, if I plug 2 back in, 2 plus 2 is 4, I'm fine to take the log of that. 2 minus 1 is 1, I'm fine to take the log of that, but it is something that we should be checking for in case we were to get an x value that when plugged in to the original would ask you to try to take a log of a negative. So finally on this fourth one, we have logs on both sides, and not only that, but every single term is a log. So I still need to condense this side, which addition turns into multiplication. So that'll be the log of 3x plus 9. I distributed that while I was at it. And then as long as it's the same base on both sides, it just cancels. If the log of one expression is going to equal the log of another expression, then those expressions have to be equal. So 2x minus 1 must equal 3x plus 9. Get your x's together, your non-x's together. And I get x equals negative 10. So this is a problem. Not because the answer is negative. X can be a negative number. It's when you plug back in that negative number that you get, you're trying to take the log of a negative 21, or you're trying to take the log of a negative 7, and so that won't check, and that's extraneous, and there are no solutions. Okay, and the last one has logs on both sides, so we can condense these two on the left. And the two on the right. And it's the same log on both sides, so cancel them and solve the remaining equation. What would we do to solve this, Bridget? Go ahead. Your x squareds will cancel. I'm going to get all my x's to the right, non-x's to the left. And then we have to reject those two, right? Because negative 1 minus 5 will be the natural log of negative 6. Can't do it. Did you solve log equations like this last year? Maybe not. So here's some kind of extension type problems, and these aren't just log questions. There's obviously right off the bat there's an exponential one. But I stole some of the questions of the even problems from the Practice Plus. This is an exponential equation. So kind of just like we did in the other one, we would want to condense this, right? So what would this become? When you multiply it, common bases, you do what with the exponents? Add. X plus 2 plus x will give us 2x plus 2. And 81 is the same as 3 to what power? Good, Andrew. And then your bases are the same, so you can drop them. And 2x plus 2 equals 4. 2x equals 2, x equals 1. Number 2, thoughts. Uh-oh. We need to play bonus game. Oh no, Olivia, go. And then divide by 3. So she got the log all by itself, which is a good first move. Then what? Aiden? Perfect. So taking what you know about solving absolute value equations, I probably would guarantee you've never solved an absolute value equation that had a log in it before. But the same principle follows because you're solving an absolute value, is that log of x either equals 2 or it equals -2. And then you're solving each of those individually. So translating 10 to the second power equals x, and 10 to the -2nd power equals x. In other words, x equals 100, or x equals 1/100. Good? And so if x was 100, the log of 100 is 2. 3 times 2 is 6. 6 minus 6 is 0. That works. If x is 1/100, the log of 1/100 is -2, but there's an absolute value sign around there, so make it 2 times 3 is 6 minus 6 is also 0. Good? So they check out. What about this one? Any thoughts with that one? It's a legitimate question because I'm stuck. I'm trying to remember what we're supposed to do here. This is a tricky one. I feel like I need a calculator, but if you did have a calculator, what would you do? Because we can just solve this and make it calculator ready. And I think that's probably what the point is just to solve it. And it's also not a log equation, it's an exponential, right? So Aiden, what would you do to both sides? Didn't you have your hand up? You could, so he's thinking turn it into log base something of something equals something. And what would that be if you did turn it back into a log? Right. And that's, by the way, what he just did there was he's just perceiving it differently than what I bet the rest of you would do. But he just took an exponential equation and he kind of translated it back to logs, right? That is essentially now what I would thought you were going to say, or what I thought most of you would say just having learned this last year, is that you would take log base 5 of both sides. So that'll cancel that, right? And then give you the exact same thing that he just did. So when you guys did do that and took log base whatever of both sides, that is essentially what you were doing. And then what do you do to both sides here? square root, very good. And so x equals plus or minus the square root of log base 5 of 50. And that's as good as we're going to get. How about 4? Morgan, what would you try first here? Okay, how so? So she's taking that natural log, turning it into that, and then it would still have minus the natural log of x, so she's taking that second layer of subtraction and turning it into this. So the natural log of a complex fraction, what would you do with that, Morgan? Good. So she's just removing the complex fraction, which would turn it into the natural log of 3 over, well, I'll just do x squared plus 5x. So now she's got it down to a single log. And then what would you do, Morgan? Go back to the front. Once we got this down to a single log, by condensing, what did we do? We're going to translate it out of log format into exponential. So what's the base? E to the, yep, right. So then e to the 0 power we should know is just 1. Cross multiply. And then solve the quadratic. So this is actually something that's going to require the quadratic formula. Yes? So negative b plus or minus the square root. B squared is 25 minus 4ac all over 2. That's 25 plus 12, 37 all over 2, and then we're done. What approximately is the square root of 37? Little over 6, right? So if you have negative 5 plus, let's just estimate 6. Negative 5 plus 6 would put you at approximately 1/2, right? Is 1/2 okay? Yes, right? Negative 5 minus 6 would put you at negative 11/2-ish, which is about negative 5.5. Is that okay? No. So even though we don't have the actual values to see what's going to be okay and what's not, we have an approximate value that's good enough for testing. And then negative 5 minus root 37 we would have to reject. So it's just negative 5 plus root 37 all over 2. Any questions on that? And then the last one, number 5. What method should we try here, Connor? Okay, so what's the right side going to become? Right, 3 squared to the 2x will become 3 to the 4x. And then the 3's can cancel, and we just have a quadratic, which is factorable, so that's lovely. So x equals 6 or negative 2. Either one of these are fine because I'm not taking a log of anything. Okie doke. Any questions? Okie doke. So you can start your homework, or